This is notes about significant figures. Significant figures are important in science because you need to be able to communicate how certain you are of a measurement, and then also if you do calculations, sometimes you'll end up with like this number with, a whole bunch of decimals, and it's just not reasonable. So these are kind of rules that help you to know, how to use them in calculations and also in measurements. So every measurement that you make has some uncertainty. So you always have to look at the markings, and then you know that you can measure certain to the marking and then just estimate one more. So what people tend to do is not to want to do that estimate, but it's actually important because then it tells people that it was marked to the previous decimal place. So for example, this one is marked in, let me see, 21. In ones, so it's marked by ones, so I should be able to go to the tenths. So it's 21 point, and then read the bottom of the meniscus, 0.4, 0.3, 0.5, those would all be correct. So you have to realize that you might not have the same exact last number as someone that you're with, but they're all correct. So a significant figure, I think like I just said, it's all those numbers that you're measuring plus that one that you estimate. And the rules that you guys covered on the POGIL, it's really easy when it's a non-zero number. It's those zeros that are tricky. So sandwich rule, captive zeros. If you have a significant figure anywhere on the left and the right, then everything in the middle is automatically significant. So for an example of the captive zero sandwich rule would be like if you have the number, 1002. The 1 is significant, the 2 is, so the zeros have to be. Zeros that are place holding are not significant, so that would be like this 0 here isn't significant. If you wanted it to be, you'd have to put a decimal. Also, those leading placeholders are not significant, so these are not significant zeros. Zeros at the number that have a decimal are significant. So what that means is, so let's say I do have that number up there again, but I have a 0 here. Now, these three are not significant. They're placeholders. They're important, but these are the 3 Sig Figs. Also, just another example, kind of a combination of these would be like if you have the number, let's say 100.00. These zero, I'm getting messy. These zeros are significant because they're following a decimal and a number. So if these are significant and this is significant, then these all count because of the sandwich rule. So this would have 5 Sig Figs. Exact numbers, things that you can count like cats and apples and cars, those are going to have infinite significant figures, but also anything defined. There's exactly 100 centimeters in a meter, so those would technically have infinite Sig Figs. So here are some practice problems. I think you should pause the video, try them, and then we'll talk through them. So let me just go through each one. So this one's a nice easy one. 3 significant figures. They're all non-zeros. This one here has 1, 2, 3, 4 significant figures. This guy doesn't count unless you had a decimal. This one here has only 1. These zeros are not significant. They're place holding, just like that 0. Over here, this one also just has 2. Here, these are place holding, leading zeros, but the 2, the 4, and the 0 are significant, so this has 3. This one now, because you put that decimal there, has 3. I call that the pickle rule. So it's like the sandwich rule, except for you don't have the other slice of whatever. Like sandwich rule would be this with the slices, but here the pickle holds that 0, to be significant. And this is significant because it's following a decimal and a number anywhere to the left. And then we know these are, so this one has to be. So this has 4. And this one has 4. These two are leading or placeholders. The rules for addition and subtraction now, those are important because this would be like when you're in the lab, your answer can't be any better than whichever instrument you used that was the least precise. So our rules for adding and subtracting are that we would just go with the least amount of decimal places. So for example, like a graduated cylinder like this, I would be able to get a measurement of 43.6. And then let's say that I have a volume of 230. I wouldn't normally use a beaker, but every once in a while. And I add those together. So this is the one that's kind of weak. And because of that, what I do is, and a lot of times I do the adding like kind of like I'm back in elementary school, and I line them up so that I can really see this. And then what I do is I draw an actual line. Like I can't go past the 1 spot because of this, weaker instrument. So then that's where I'm going to cut it. I say I'm going to cut the number or round the number. And then I look back 1, and if it's 5 or greater, round up. So my answer would be 274 milliliters. Here's another, addition problem. So you can see that this guy going to the tenths is the weakest measurement. So you can only go to the tenths. And then again, looking back, only 1, 5 or greater, round up. So the answer here would be 1459.1. So here's another problem. You could try it and then pause and see. When you subtract here, again, you may find it helpful to actually stack them. 0.0560. If you're a visual kind of learner, you can see right there's where I'm going to need to cut. So when I do this, I get 0.00698. And I can only go to this decimal place. The 8 tells me to round up, which would make that a 10 and that a 7. So my answer would be 0070 meters. Multiplying and dividing, the rules are different than they are for adding and subtracting. So now you're not going to look at decimal places, but you're going to look at significant figures. And your answer can only have the least amount of significant figures. So this number has 4 significant figures, and this has 2. So my answer can only have 2 significant figures. So I would pause the video and try these 2 problems. So when I multiply these, my calculator is going to tell me that it's 6.48024. Unit-wise, the grams per cubic centimeter, you could think of that being in the denominator. The cubic centimeters cancel, and it would be gram. But I do want to round this with 2 significant figures. So 1, 2, cut, look back only 1, and round up. So the answer would be 6.5 grams. This one here, my calculator is going to give me a lot of numbers. It's like 15.17678,571. And I can only have 2 Sig Figs because of this measurement. This one has 5, but I go with the least. So 1, 2, cut. So my answer is just going to be 15. Unit's going to be grams per milliliter.